In this video, you will be taking notes on standard and scientific notation. We'll be talking about what standard notation is and what scientific notation is. So the first part, like we do in all of our journal entries, is to go to the table of contents, first page, and skip a line underneath where you wrote PEMDAS, and write standard and scientific notation, and it's going to be on pages 25 to 29. So we're going to have several pages in our journal for standard and scientific notation. And again, you may stop the video whenever so that you can get this written in the table of contents. Alright, so then turn ahead to page 25, and I believe the last page that you have written in your journal is page 23. You did some examples for PEMDAS on page 23. So I'd like you to number page 24, but then put an X through page 24. We will not be using page 24. And then turn and number page 25. And at the top of page 25, please write standard and scientific notation. So that's at the top of page 25. And then our goal, and what we will be doing in this unit, says this: I will write numbers in standard form and scientific notation. I will add, subtract, multiply, and divide numbers written in scientific notation. Okay. So this can be written on a line below, below the top where you wrote standard and scientific notation. And then the goal again, I will write numbers in standard form and scientific notation. I will add, subtract, multiply, and divide numbers in scientific notation. And we will talk about what standard form is, and we will talk about scientific notation. All right. Then, underneath where you just wrote the goal, so you have the goal, skip one line, and then you're going to make a table that looks like this. Okay? It's 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. So in your journal, count down 9 lines. I don't know how well you can see my journal, but I wrote or counted down 9 lines, drew a line, went all the way across the journal, made that rectangle, and then in the middle, divide it in half. So we've got 9 lines divided in half. And then at the top, in the top bar, the top space, standard notation. And on the right-hand side in that top space, scientific notation. And again, stop the video at this point and copy what I have up here. 790, 23,400, 0.00561, 0.0000, 8013, and then underneath here, write those on the bottom 4 lines. Paying close attention, this is a -3, and this is a -6. So again, stop the video. Stop the video if you need to get that put in your journal on page 25. All right, so top line, I give you the number 790. That's standard form. Standard notation means the regular way that we write numbers, the way that we've always written numbers, 790. So our job is to write that in scientific notation. So the rules say for scientific notation, I start here and I look for the first digit that is not a 0. First digit that's not a 0, which is 7, so I'm going to write 7, and then I'm going to put a decimal behind the 7. Copy everything else until I have only zeros. So in this case, it's just 7.9, because now I've got a 0, so I don't need to put the 0 with this. And then times 10. Scientific notation always has the times 10. Now we need an exponent. Okay, so we go back here. If I have to put my decimal here, I would need to move it 2 places to get back to the end where it was. So I put my decimal here, 2 places to the right, so it's a positive 2. 7.9 times 10 to the second. These two are the same number, they equal the same amount. This one written in standard notation, standard form. This one written in scientific notation. So we take our next number, okay? I start and I find the first digit that is not a 0, and I put my decimal behind it. So 2 point, and then I'm going to copy everything else until there's only zeros. So 2.34 times 10 to the, I need an exponent. So the decimal needs to go here, 1, 2, 3, 4. Let's count it again. The decimal goes here, 1, 2, 3, 4. 4 to the right makes it a positive 4. And again, this number in scientific notation is the same as this number in standard notation. So let's take a look at the next example. This time we have the decimal in there. Okay, so it's really the same rule. For scientific notation, we look for the first digit that is not a 0. And in this number, it's the 5. So I'm going to put 5 point, that's where the decimal has to go. And then I'm going to copy the rest, 5.61 times 10 to the, now we need an exponent. This one is a little different because the decimal is here, and we're going to go to the left to where the decimal was. So we start here, right, it's after the 5, and we're going 1, 2, 3 numbers, 3 digits to the left. When we go to the left, it's a negative exponent. So 5.61 times 10 to the negative 3. Let's take a look at this one. We've got a lot of zeros up front, but as we've said in the other examples, scientific notation, we look for the first digit that is not a 0. So we have to go a little ways and we come to the 8. So I'm going to put 8 point, and then I'm going to copy everything else until there's only zeros. So in this one, I need the 0 because there are other numbers behind it. So 8.013 times 10 to the, so the decimal has to be here for scientific notation. This time we're going 1, 2, 3, 4, 5 numbers to the left, or 5 digits to the left. So here we count again. It needs to be here, 1, 2, 3, 4, 5. 5 to the left is a negative exponent. So now in the bottom 4 examples, you're given the number in scientific notation and you have to write it in standard notation. So we look, okay, the decimal's here after our first non-zero number, times 10 to the 5th. This is a positive 5. So positive 5 tells me the decimal is going to move to the right that many places. Okay? So we have 6, right? 1, 2. right? The decimal was here. Here's 1, 2, 3, 4, 5 places. And I check, count again. It started here, and I'm going 5 to the right. 1, 2, 3, 4, 5. And I'm going to put a comma there to make it easier to read. This one, we notice times 10 to the 6th. Positive 6, so that tells me the decimal is going to go to the right 6 places. So I start with my 9 and 8, okay? And I go back. I know that the decimal started here. So here's 1 place, 2, 3, 4, 5, 6. And I count again just to make sure it was here. 1, 2, 3, 4, 5, 6. I can put it at the end if I want, and put in commas to make it easier to read. And again, these two numbers are the same. They have the same value, written in scientific notation, written in standard notation. Here, we look carefully, it's times 10 to the negative 3. Negative 3. Negative 3 means the decimal is going to go to the left. It's going to go to the left. And in this case, it's going to go 3 places to the left. So I'm going to put 3 and 4 there, right? My decimal started here. I'm going to the left. 3. 1, 2, 3. Put in the decimal and add a 0 up front. And we check. It was here. 1, 2, 3. And our final example, okay, the decimal's behind that first number that is not a 0. Negative 6. Negative 6 is going to the left 6 places. So I'm going to copy this. Okay, the decimal was here, and now I'm going 6 to the left. So there's 1, 2, 3, 4, 5, 6, and then the decimal, and a 0 out front. And we check, it was here, right, behind the 8. 1, 2, 3, 4, 5, 6 to the left. So that's correct. So that's how we write numbers from standard notation to scientific, or scientific notation to standard notation. And again, stop the video if you need to. And then we're going to go on in the videos to the next part. Okay? This is still page 25. Still page 25. You should have some room underneath your chart in my journal. Here's my chart, and then I've got some room underneath yet. So I would like this to still fit on page 25 if you can. And if you need to write here in the margin any of this, that's fine, you may do that. But please try to keep this on page 25. Alright, so a couple of things to keep in mind with scientific notation is the decimal goes behind, okay, goes behind the first non-zero digit. So the first number that is not a 0. Here are a couple of examples. 5.987. This is the first digit that is not a 0. Put a decimal behind it. 3.01. 8.1765. Okay? Please write that and write those 3 examples. All right. The next part, a positive exponent. Positive exponent. Please make sure you underline positive, or you could highlight it also. But a positive exponent tells the decimal to move that many places to the right. Okay? If we go back a page here, Right, remember, in this example, we said it was a positive 5. So the decimal is going to move 5 to the right. 1, 2, 3, 4, 5. Right, so a positive exponent tells the decimal to move that many places to the right. And then the final thing to write on page 25, a negative exponent tells the decimal to move that many places to the left. And then I wrote same is true for division. I'll show you what that means here in just a moment. So make sure you copy that as well. Okay? Negative exponent tells the decimal to move that many places to the left. And if we go back quickly, right, here's a negative 3. The decimal was here, and I moved it 3 to the left. 1, 2, 3 because of the negative 3. Right? And one example, okay, so I wrote here, same is true for division. Right, so if we had this, for example, 4.176 divided by 10 to the 4th, because of this division, the decimal is also going to move to the left. Right, so it was here, 1, 2, 3, 4, and then the decimal and a 0. Okay? So if it's a negative exponent, or if it's division, the decimal moves to the left. That will conclude this part of scientific notation. Again, go back, make sure that you have everything here on page 25 that I have up here on the smartboard.